Welcome to our second lesson on reactions in aqueous solutions. We'll be looking at an experiment on the conductivity of some solutions. Now we're going to make up a solution of water and sodium chloride, then another solution of water and potassium permanganate, of water and sodium hydroxide, and then of water and hydrogen nitrate, also known as nitric acid. We will then set up the apparatus as follows. And here we're going to be dipping 2 electrodes. Now electrodes are substances that can conduct electricity, and in most cases one of the best electrodes that we end up using is that of graphite. Now graphite is made up of carbon and it's a good conductor of electricity. So we place these electrodes inside the solution, make sure that they do not touch each other. So the solution is either then that of sodium chloride in water, or potassium permanganate in water, or the sodium hydroxide, or the hydrogen nitrate in water. We connect then our electrodes at the top with connecting wires to a battery. Now note the long line of the battery is the positive part and the short line is the negative, as you can remember for your electric circuits. And seeing that we've got 2 pairs of positives and negatives, this means our cell, or a battery in this case, consists of 2 cells. Now we will also have a bulb inside the circuit. Now if the circuit is completed, that means this gap here at the bottom is overcome by one or other ion that might transfer the electricity, then our bulb will glow. But if this gap at the bottom is not overcome by any ion that can transfer electricity, then this bulb will not glow. So the moment that we place our electrodes into the specific solution and the bulb starts to glow, then it means that solution can conduct electricity. So we pour in our sodium chloride together with water. Now we would note that our sodium chloride does dissolve very good in water. I'm sure you might have seen salt dissolve in water before. Now when we do place it in, we'll note the bulb glows. So that means that it does conduct electricity. And the bond that is found between the sodium and the chloride is an ionic bond. The next one is potassium permanganate. Now this also very readily and easily dissolves into water, and it also does conduct electricity because the bulb will glow the moment that we place our electrodes into the potassium permanganate solution. Now potassium permanganate is also an ionic bond because it's made up of potassium ions and of permanganate ions. Remember, permanganate was one of your polyatomic ions which you had to know of by heart. Then our sodium hydroxide also readily dissolves into water, that means easily. It does also conduct electricity because the bulb glows, and it's made up of sodium ions, which is a metal, and oxygen and hydrogen, which is a non-metal, so therefore it's also an ionic bond. Then we've got potassium nitrate. It does also readily dissolve into water. It conducts electricity quite well, and then we'll note it's made up of potassium ions, which is a metal. The nitrate ions, once again, is in this case your polyatomic ions that you also need to know of by heart, which is made up of nitrogen and oxygen, which are non-metals. So our potassium nitrate is then also an ionic compound. So our conclusion which we can draw from this is that all ionic substances that dissolve into water will be able to conduct electricity. Now let's take a look at hard water. Now you might have heard the term before, hard water. Now what it actually means is that it's water that contains a lot of dissolved calcium and magnesium ions. Now the presence of these calcium and magnesium ions then makes the water as such hard because it doesn't really want to lather any soap, and it has a specific taste to it as well. Now it is actually not dangerous to you whatsoever. It would be though good to you because calcium ions are used in your body to help build strong bones. But because of the other properties that it also has, as we said, this more funnier taste, and the fact that your soap doesn't really want to lather, means then that we do not actually want potassium ions and magnesium ions when we want to do washing, etc. Soft water, on the other hand, will then contain a great amount of sodium ions and of chloride ions inside of them. Now we can go and change our hard water to soft water by making use of an ion exchange device. Now, this ion exchange device would then be filled with a lot of sodium ions that's attached to a resin. Now, what we just referred to the resin here is the fact that it is almost like a material that this sodium ions can attach to. So this material is then fully attached by sodium ions, and what we will do then is we will then pour our hard water through this resin with the sodium ions that's attached to it. Now, because this resin would rather want to attach to positive ions, and noting that our calcium ions and magnesium ions has got a higher positive charge than our sodium ions has, it will then kick out my sodium ions, and where the sodium ions are kicked out, the calcium ion and or the magnesium ions will go and attach. So as the water keeps on flowing through this ion exchange device, it will attach all the magnesium and calcium ions and remove them then from the water. And then as they are removed, then the sodium ions then have to be replaced with them, and therefore our water at the end will contain a lot of sodium ions and therefore make it then soft water, which will then in this case lather soap quite well. And it does also taste a lot better. Now, when my ion exchange device has attached all of the magnesium and calcium ions that it possibly can, then it won't be able to remove magnesium and ions from the coming water. So what we would need to do then is to reverse this process again. Now, we would then pour in a highly concentrated sodium chloride solution into this device, and remember, sodium chloride consists of sodium ions and chloride ions, and because it's such a high concentration of the sodium ions, they will then force the magnesium ions and calcium ions out of the resin. And then once again they will start to attach to the resin, which can then be again used to remove our calcium and magnesium ions from the hard water. Now, acid rain is also another form of where we've got aqueous solutions with reactions in them. A typical example is all the gases in our atmosphere, which do constitute of carbon dioxide gas, nitrogen dioxide gas, and sulfur dioxide gas, will dissolve when rainwater is falling. Now, this rainwater then dissolves these gases, and then they form the following respective products. Our carbon dioxide ends up forming carbonic acid, which is H2CO3. Our nitrogen dioxide, together with water, will form nitric acid, which is HNO3. And our sulfur dioxide will combine with water to form sulfurous acid, which is H2SO3. Now, all of these acids are fairly weak, with the exception of nitric acid. And this will then lead to the corrosion of buildings as well as metal structures, specifically iron structures. Now, the question which I would like you to go and attempt is to predict which one of the following substances will conduct electricity when dissolved in water, and also mention the type of bond that there is between the atoms within the molecule. So the first one is magnesium chloride, and the second one is methane, which is CH4.